Dear students, our topic for today is liver. The liver is the largest exocrine and endocrine gland of the body. It is located in the upper right part of the abdominal cavity. Functions of the liver are metabolism of carbohydrate, fat and protein, detoxification of drugs and poisons, storage of glycogen and fat-soluble vitamins like A, D, E, K, and secretion of bile. The liver lies in the upper right part of the abdominal cavity, occupying most of the right hypochondrium and epigastrium and extending into the left hypochondrium. The liver is wedge-shaped and resembles a four-sided pyramid laid on one side with its base directed towards the right and apex directed towards the left. The wedge-shaped liver presents two well-defined surfaces, diaphragmatic and visceral, and one well-defined border, inferior border. The diaphragmatic surface is convex and extensive. It faces upwards, forwards, to the right and backwards. The visceral surface is relatively flat and faces inferiorly. These two surfaces meet in front at the sharp inferior border. The diaphragmatic surface is subdivided into superior, anterior, right lateral and posterior surfaces, but there is no distinct demarcation between these surfaces. The diaphragmatic surface includes smooth peritoneal areas which face superiorly, anteriorly and to the right, and a rough bare area which is devoid of the peritoneum and faces posteriorly. The superior surface is convex. The anterior surface is triangular, slightly convex. Much of it is in contact with the diaphragm, which separates it from lower ribs and the costal cartilages. The right surface lays next to the right dome of the diaphragm. The posterior surface is triangular. On the diaphragmatic surface, the peritoneal ligament, which is called the falciform ligament, separates right hepatic lobe from left hepatic lobe. The visceral surface is relatively flat or concave. It is directed downward, backward, and to the left. It is separated in front from the diaphragmatic surface by the sharp inferior border. On the visceral surface, you will recognize grooves which look like letter H, which divide the visceral surface into lobes. The grooves from left side form the left sagittal fissure, and grooves from right side from the right sagittal fissure. Between left and right we have horizontal part, it's called the porta hepatis. Left sagittal fissure consists of fissure for venous ligament and fissure for round ligament, in Latin ligamentum teres hepatis. The right sagittal fissure consists of groove for inferior vena cava and fossa for gallbladder. Gateway of the liver, or in Latin porta hepatis, is a horizontal part on the inferior surface of the liver. The main structures entering the porta hepatis are right and left branches of the proper hepatic artery and portal vein, and the main structures leaving the porta hepatis are right and left hepatic ducts. Also present in the porta hepatis are lymph nodes and nerves of the liver. Grooves on the visceral surface separate this surface into four parts. We have four lobes: left hepatic lobe, right hepatic lobe, and in the middle, caudate hepatic lobe and quadrate hepatic lobe. The visceral or inferior surface have the impressions of organs in contact with it. The inferior surface of the left lobe is in contact with anterior surface of the stomach. We have gastric impression, is in contact with esophagus, we have esophageal impression, and tuber omentale is a ventral prominence elevated by the abdominal aorta. The caudate lobe consists of two processes. Medial one is the papillar process and the lateral one is the caudate process. The inferior surface of the right lobe is in contact with the right or hepatic flexure of colon, duodenum, with right kidney and right suprarenal gland. We have colic impression, duodenal impression, renal impression, and suprarenal impression on the right lobe. Most of the liver is covered by the peritoneum. The area which are not covered by the peritoneum is bare area of the liver. It is a triangular area on the posterior aspect of the right lobe. The bare area of the liver is in direct contact with the diaphragm, which separates it from the right pleural cavity. The peritoneal structures of the liver are falciform ligament, coronary ligament, and lesser omentum. The falciform ligament is a thin anteroposterior fold consisting of two layers of peritoneum. One of its three borders is attached to the anterior surface of the liver. Another border is attached to the diaphragm and the anterior abdominal wall to the level of the umbilicus, while the third, inferior border is free and encloses the round ligament of the liver. The falciform ligament is a sickle-shaped fold of the peritoneum connecting the liver to the umbilicus, which encloses the round ligament of the liver. The round ligament of the liver represents the obliterated umbilical vein. The coronary ligament has upper and lower layers, united laterally at angular extensions, forming the left and right triangular ligaments. The peritoneum forming the coronary ligament reflects from the liver onto the diaphragm to enclose an area devoid of peritoneum. Here the liver is in direct contact with the diaphragm and it is a bare area. The lesser omentum is the fold of the peritoneum connecting the lesser curvature of the stomach and duodenum to the visceral surface of the liver. The portion of the lesser omentum extending between the liver and the stomach is called the hepatogastric ligament, and the part between the liver and the duodenum is called the hepatoduodenal ligament. The hepatic attachment is G-shaped, with vertical limb being attached to the margins of fissure for venous ligament and horizontal limb being attached to the margins of porta hepatis. Now the thumb and index finger show you position of hepatoduodenal ligament and hepatogastric ligament. On the visceral surface of the liver, in left sagittal fissure, we have two parts of the peritoneum. It is the round ligament of the liver and venous ligament of the liver. Round ligament of the liver is the remnant of the obliterated umbilical vein and extends from the umbilicus to the left branch of the portal vein. Venous ligament of the liver is the remnant of the obliterated venous duct which in fetal life connects the left branch of the portal vein with the inferior vena cava. Outside the liver we have lobes, but inside the liver we have segments. Segments are divided by branching pattern of the blood vessels and biliary tree. The inner segmentation does not correlate with the pattern of lobes as seen from surface. The left and right lobes of the liver function separately. Each lobe has its own arterial supply and venous and biliary drainage. A horizontal plate through each lobe divides the liver into 8 segments. Division of the liver into segments allows surgical removal of particular segments according to their blood supply. The liver consists of hexagonal lobules made up of plates of hepatocytes radiating away from the central vein. The bile produced by hepatocytes first enters the bile canaliculi situated between the opposite sides of the hepatocytes. The bile canaliculi drain into the bile ductules of the portotriads, which in turn unite to form the larger intrahepatic ducts. These plates of hepatocytes are separated by vascular spaces called sinusoids, which connect the portal vein of the triad to the central vein of the lobule. The blood flow in the sinusoids is from the periphery of the lobule toward the central vein. The hexagonal structure with 3 portal canals in the corners draining into one central vein is defined as a hepatic lobule. At the periphery of the lobules in the corners are portal triads in the portobiliar space. Each triad contains 3 structures: bile duct, hepatic artery, and portal vein. At the periphery of the lobules in the corners are portal triads in the portobiliary space. portal triad of Gleason consists of interlobular artery, interlobular vein, and interlobular bile duct. Interlobular artery is a branch of the proper hepatic artery. Interlobular vein is a branch of the hepatic portal vein. Interlobular bile duct is a branch of the biliary tree. The portal triads are embedded in the perilobular connective tissue. In the liver we have three units: the basic anatomical unit, the principal unit of circulation, and the primary functional unit. Classical hepatic lobule, or the basic anatomical unit, is made up of plates of hepatocytes radiating away from the central vein. Portal lobule of mole, or the principal unit of circulation, is a triangular shape where the corners are represented by three central veins and the portobiliary space are located in the center. In the hepatic acinus, or the primary functional unit, the portal canal forms the center and the central veins form the corners of two hepatic lobules. The liver has a double blood supply from the hepatic artery and the portal vein. The right and left hepatic arteries carry oxygenated blood to the liver, and the portal vein carries venous blood containing the products of digestion. In functional circulation, blood from the abdominal organs enters the liver across the hepatic portal vein to the interlobular veins, which give off the circumlobular veins that surround the hepatic lobule and empty into the hepatic sinusoids across the precapillary veins. Blood in the sinusoid supplies hepatocytes with oxygen and nutrition and flows to the central vein, sublobular veins, hepatic veins, and finally to the inferior vena cava. In nutritive circulation, blood flows from the proper hepatic artery to the interlobular arteries, which give off the circumlobular arteries that flows across arterioles to the terminal parts of the hepatic portal system. The nutritive system oxygenates the wall of the veins and hepatocytes. The liver is a highly vascular organ. It receives blood from two sources. The arterial blood, oxygenated, is supplied by the hepatic artery, and venous blood, rich in nutrients, is supplied by the portal vein. Arterial supply are from the celiac trunk. The common hepatic artery rises from the celiac trunk, after giving off the gastroduodenal artery as the proper hepatic artery ascends in the free edge of the lesser omentum and near the porta hepatis divides into the right and left hepatic arteries. The venous supply are from the hepatic portal vein. The hepatic portal vein is formed by the superior mesenteric vein and splenic vein. Most of the venous blood from liver is drained by three large hepatic veins: left hepatic vein between medial and lateral segments of the left lobe, middle hepatic vein between right and left lobes, and right hepatic vein between anterior and posterior segments of the right lobe. They emerge in the upper part of the groove for inferior vena cava and open directly in the inferior vena cava just below the central tendon of the diaphragm. The three veins may enter the inferior vena cava independently, but the left and middle veins usually join, so that only two major veins join the inferior vena cava. Inside the liver, we have venous anastomosis or portocaval anastomosis. The lymph from the liver drain into hepatic nodes and celiac nodes. Liver is innervated from celiac plexus. Parasympathetic fibers descend across vagus nerve. Sympathetic fibers descend across the greater and lesser splenic nerve to celiac ganglion. The sympathetic and parasympathetic nerve fibers reach the liver along its arteries from celiac plexus. The sympathetic fibers decreases production of bile and increases glycogen and protein catabolism. The parasympathetic fibers decreases glycogen and protein catabolism and increases production of bile. In the myth, the god Zeus decrees that fire is not to be given to humanity, as they do not deserve it. Prometheus steals fire from Mountain Olympus to give to the humans. Zeus punishes Prometheus by having him changed to a rock in the mountain. One eagle eats his liver every day, but his liver grows back every day. It is very interesting that in that time the humanity knows about potential of human self-regeneration. Dear students, if you have questions about liver, please send me email.